7.4, quadratic versus linear relationships, and we're really going to focus on that, looking at tables today. So look at example number 1. We're supposed to decide whether these numbers represent a linear, quadratic, or some other kind of relationship. We're really going to focus here just for a few minutes on how to do that with just looking at these numbers. And we're going to focus on the differences between the y values. Before we get started, please notice the x values are going up by 1 every single time, which means I don't really need to look at y over x because the x's are all going up by 1. So I'm really just going to concentrate on the y's because of the numbers in these tables. So let's look. If I get from 21 to 14, that means I went down 7. 14 to 9 means I went down 5. So right off the bat, you should know these are not linear. Because linear, I would have constant differences. They should be the same because my x's are going up by the same. But if we keep going, we see, let's see, subtract 3, subtract 1, then we add 1 to get from 5 to 6, and we add 3 to get from 6 to 9. So it's not linear. In fact, let's write that down. These numbers, since they don't match, tell us that this relationship is not linear. So let's look at the next option. Once we have these first differences, which is what we call the red numbers, we can look at second differences, which is what I'm going to do in blue. So to get from negative 7 to negative 5, I'm going to add 2. Negative 5 to negative 3, okay, it looks like I'm also adding 2. I'm feeling good about this. I'm going to add 2 again. Negative 1 to positive 1, I'm going to add 2. And finally, 1 to 3 means I'm adding 2. This tells us the relationship is quadratic because the second differences, which is what those are called, match. Constant second differences mean that it is quadratic. Now I will show you a method that your calculator can really help you to figure this out in a minute, but it's really not too terrible to look at it by hand. Let's look at the next one, example 2. Again, my x values are all going up by 1, so I can kind of take for granted that I don't have to worry about those. So to get from negative 3 to negative 4, we subtract 1. Negative 4 to negative 5, we subtract 1. Okay, I think we can all see the pattern. Each of these y values is going down by 1. All right, which means that it is in fact linear because my first differences are matching. Hopefully that makes sense because my differences are constant, just like a linear equation increases or decreases constantly. All right, let's go ahead and look at the next example, example number 3. All right, again, my x's, we don't really need to worry about them. Let's just focus on my y's. To get from negative 69 to negative 31, I'm going to add 38. 31 to 11 means I'm going to add 20. Negative 11, okay, now I'm adding 8. And then I'm adding 2, and then I'm adding 2, and then I'm adding 8 again. So we know it's not linear, right? This column tells us it's not linear because those numbers are not matching. Then we move to the next one. Second differences, we're checking quadratics. Well, it looks like I'm subtracting 18 to get from 38 to 20. Looks like I'm subtracting 12, and then I have to subtract 6, and then I don't do anything, so I'm going to put a plus 0, and then I add 6 to get from 2 to 8. Okay, well these numbers are not matching, so it's not quadratic. So in this case, we're just going to go ahead and call this other. This is a function we may look at towards the end of the year. All right? Okay, finally, last but not least, let's talk about how our calculator can help us out. The first thing I want you to do is I want you to follow the instructions to turn on your diagnostics. This is going to make R show up, which is enormously helpful. So to do that, we got to go to our catalog, which is this button right here by 0. So we're going to do second 0. Takes us to our catalog, and we're going to go down to the diagnostics. So we can scroll forever, or I can just see this green letter D. I can press this button to get me down to letter D's here. We're going to go down to diagnostics on. We want to turn them on. Let's see. There we go. So diagnostics on, we're going to press enter. And I need to see done here to know that I actually have them on. All right, my diagnostics are on. Perfect. And now we can go ahead and we can talk about how to get a quadratic regression from our calculator. We've got a table. And what do we do when we have tables? We do stat edit, right? So we're going to follow these directions and get our examples, the numbers for the tables. Here we go. Stat, edit. We're going to type in the numbers that we see. So we've got a negative 6, and we've got a negative 5, and a negative 4, negative 3. And then in our y's, let's see, 56, 36, 20, and 8. All right. 20 and 8. So what we want to do, we did the first step, right? We did this first step. We put these numbers in. So we're all the way now down to step 4. We're going to go back to stat. We're going to go over to calc. Now, y'all, we're going to choose option 5, which is quadratic regression. In the past, we've always chosen option 4 because we were always doing lines. Now that we're not doing lines, we're doing quadratic equations, we choose quadratic regression. We want option 5. And it gives us, let's see here, gives us A and B and C. So take a look at my notes. I have places to write those numbers. So if A is 2, and B is 2, and C is -4, and then I have to write my equation. Well, remember, my formula is ax squared plus bx plus c. And this right here is what I'm using to write my equations. Okay, so what we're going to do, say y equals ax squared. Okay, well, in this case, that's 2x squared plus bx. All right, well, in this case, that's 2x. And then finally, plus c, which I can just write -4. So here's my equation from that given table. All right, now we're going to do one more example, and I'm going to try and go as quickly as possible. We're going to go to stat edit again. I'm going to do example 2. My x's are the same, which is really nice, so now I just have to change my y's. So I'm going to type in over my numbers there, 70, 54, 40, and 28. All right, so we're going to go to stat, calc, option 5. I'm just press the number 5, and enter, enter, enter. All right, and now they're telling me that A is 1, B is -5, and C is 4. So my equation for this is 1x squared. I don't need to write the 1, and you probably won't see the 1 if this is a multiple choice question, so let's just leave it off. And then plus 4. All right, there's my equation. Pretty simple, right? Now, the only thing I have to show you now is when to choose when, or how to figure out which one is the one that you need. Because if I don't tell you it's linear, you don't know to choose option 4. If I don't tell you it's quadratic, then you're not sure to use option 5. So we got to know which one's which. And the R value is what's really going to help us here. So I'm going to put in the numbers from example 3. All right, we're going to go to stat edit. I'm just going to type right over the numbers in my lists. So I've got 2 and 3 and 4 and 5. And then my Y values are 20 and 48 and 84 and 128. Okay, so this is great. Now that we have them in here, we're going to go to stat. We're going to go over to calc. Now, I could do the whole first difference, second difference thing, but let me just show you how your calculator can help you. What if I just want to test some things? I'm going to choose option 4. And I do get an answer. And I'm going to tell you it's not the right answer, and the reason I know this is because R. Look at R. Guys, when I don't get a 1 for R, that means that it's not linear. The only time the R value is not 1 is if we've got a scatter plot or something crazy. No, this is supposed to be 1. R should be 1. So that's telling me that's not linear because I didn't get a 1. So now let's check quadratic. So we're going to check option 5. Okay, and then this time, do I get a 1? I do. So this is the one that I want because I got an R value of 1. So this is quadratic. All right, so we've got y equals 4x squared, right? I'm taking the numbers from my calculator. 4x squared, because A is 4, plus 8x, because B is 8, and then minus 12. We're not using those R values. They just tell us that our data is good. They tell us if our data is a perfect relationship or not. And then finally, we've got example 4. I'm sorry you guys have to watch me click here. I'm trying to go as fast as I can. We're going to stat edit, and we've got 4 new x's to type in here. So -3 and 0 and 6 and 12. And then we've got -13, -11, -7, and -3. All right, so stat, calc. Now which do I choose, linear or quadratic regression? Well, let's try both. If I do choose linear first, let's see if I get a good answer. Okay, I do. Look, R is 1. This is perfect. So I got A is 0.6 repeating, which we know that is actually 2/3, right? and then we get b is negative 11. So my equation here, since it's linear, is just y equals, remember the first number is my slope, so 2/3 x, right? Or you can look at the form they give you up here if you kind of forget how it works, and then minus 11. Really quickly, what if we had chosen quadratic? This is important. What if we had chosen option 5, quadratic regression? Look at what we get. We get an R value of 1. Okay, that's confusing, unless, look at the fact that we get an A value of 0. And I'll erase this in a second, y'all, but if I write that down, wouldn't I get y equals 0x squared plus 0.6 repeating, so plus 2/3 x minus 11? I definitely need you to understand that I don't write this. So I would have been left with y equals 2/3 x minus 11. So even though we did a quadratic regression, because the a value was 0, it ended up linear. This is important, okay? I'm sorry I keep saying that, y'all. Listen, if I don't have x squared, I don't have a quadratic relationship, okay? You have to have x squared for your equation, for your function to be quadratic. Awesome. So last but not least, just to kind of recap, how does your calculator help you decide if you have a linear or a quadratic function? And we're just going to say, just in general, look at r or r squared, right? It should be 1. Okay? So you guys remember, you can do it by hand looking at the first differences or the second differences, or if you want to use your calculator, that's fine. Just remember, you're looking for an R value of 1 and you're paying attention to whether or not you get an A value of 0, because that's a little bit tricky like the last one we did.